Alrighty, we are on with another insulation tester comparison video. This comparison was also requested by the Electrician's Tool channel, along with Alan Sparks as well, who also requested the Flir against the Megger MIT420. Electrician's Tool channel didn't specify, so I thought I'd chuck in the Megger MTR105 into the equation as well. But I don't mind admitting this one has given me a bit of a headache because these are three quite different instruments, all individual in their own respects really. So what we have here is on the left the MIT 420/2. This is part of the Megger's standard industrial range of insulation and continuity testers. This is number 3 in the range, so it's not top of the range, but it's also not the very basic instrument either. Recommended retail price in the UK is around £660. Next to it is the Flir IM75. This is marketed as an insulation multimeter. Pretty unique instrument within the range from Flir, and sells recommended retail prices around about £735. Both of these two instruments I can get deals on somewhere between 25 to 30% reduction in price. The MTR105, this is a different instrument. This is a rotating machine tester, again from Megger. Retails for £2,000, so very upmarket instrument. I have seen this instrument with the VAT knocked off of it, a 20% discount. Okay, so we'll look at the insulation test function first on these instruments. As you can see there, so for all the instruments the test voltage is selected from the rotary function switch here, 50 to 1000 volts, 100 volt, 250, 500 volt steps on the MIT 420, and that matches the Flir IM75. However, the Megger does not have a 100 volt fixed setting. It's 50, 250, 500, 1 kV for the MTR105 here, but both of the Megger units do have a variable function at the end, and obviously with this you can pick this up at 100 volts if you use that test voltage. A variable function is quite useful for me in my work. I have DC systems at 120 volts and generator rotors that can have all kinds of weird ceiling voltages or max excitation voltages that I can set the instrument to and test at that voltage level and get a better test than just using one of the standard test functions there. I'll put a little table up of the actual test ranges for these instruments. For the Flir at 1000 volts it can go up to 20 gigaohms, but both these Meggers can go up to 200 gigaohms, so significant increase in capability in that respect. At 500 volts this will drop to 500 megaohms, but the two Meggers will drop down to 100 gigaohms. So again, significantly better offering than you get with the Flir there. In terms of overall accuracy for the insulation test function, they're all pretty much the same really, not too much in it, 0.2% up to 0.4% for the MTR105 there, but in real terms when you're actually testing something, the difference is nothing to worry about really. Okay, so moving back to the voltage function there, which is on the other main function scale for this instrument, and it's the first function on the Flir here as well. It's quite a nice feature because as you've tested and carried out an insulation test, as part of switching the instrument off, if you leave it connected you can wind it back to the voltage and see if there's any voltage left on the test object. In terms of functionality for volts, the Meggers here have AC DC function, AC only function and DC only function, and it defaults to the AC DC mode when you turn it on, same as the MTR105 here, defaults to AC DC, and you have your AC function there, DC function there. You also have a 3-phase mode on the MTR105, which will also include a phase rotation test that you don't get on either of these other two instruments. For the Flir it defaults to AC mode, and you can change that to a DC mode, but there is no AC DC, it goes back to AC from there. but what you do get with the Flir that you don't get on the 2 Meggers is a separate frequency. So you can, the main display there will display the frequency on both these instruments. For the Meggers, the frequency is displayed as a secondary function. Here it will be displayed up here on the MIT420 and on the grey bar here on the MTR105. In terms of voltage specification, the Flir here will measure from 0.1 volts to 1000 volts. Cat 4, the Megger MIT420 will read from 0.1 millivolt up to 600 volts, also Cat 4, whereas the MTR105 is 10 millivolts up to 1000 volts, but it's only Cat 3 rated. In terms of the frequency, both the Meggers will display between 15 Hz to 400 Hz, as I say, only as a secondary function on the screen. The Flir can display from 3 Hz up to 30 kHz, so you start to see the multimeter aspect of the Flir coming out there. Next one round on the Flir is for capacitance, diode and continuity. To get to that kind of function on the 2 Meggers, you spin him around on the other side of the off switch. Both the Meggers have a fully automated continuity and resistance function, and both the instruments will read from 10 milliohms up to 1 mega ohm. Test current on both the Megger instruments is 200 milliamps up to 4 ohms. On the Flir, to actually get to the resistance reading, that's split from the continuity function there, and you have to move them around to another setting on the function switch. That will read up to 40 kilo ohms, so much lower resistance reading capability than the 2 Meggers. 200 milliamps, it can measure up to 10 ohms, and again it's an automatic function. All 3 instruments have a lead zeroing function built into them as well that you can use. Where the MTR105 tends to outshine the other 2 instruments is this 4-wire resistance mode here. In 4-wire mode it can measure from 0.01 milliohm up to 10 ohm, again as either a 20 milliamp or a 200 milliamp test current. So that gives you a much more accurate reading for testing winding resistances of motors. I didn't think I'd use it that much. As I've used the instrument, I found I have used it and do actually quite like the 4-wire function of the instrument. It is very useful. Okay, so if just flipping back to the second function here on the Flir, it also gives me capacitance and diode. You do have a capacitance function on the MIT420. That will read from 0.1 nanofarads up to 10 microfarads. On the Flir, it will read from 1 microfarad to 10 millifarads. So quite a crossover of the 2 ranges between these 2 instruments. I'm quite surprised really. I would have thought as a multimeter it should have read lower than the 1 microfarad, and when you are reading the microfarads there is no decimal point on the instrument. So if you're reading a 2.2 microfarad or 4.7, you just get 2 or 5. So it's not the most accurate of functions, given that it is marketed as a multimeter. For the MITR105, this has an LCR meter built into it with capacitance capability from 0.1 nanofarads up to 1 millifarad. So pretty good range for this instrument, and on top of that, with it being LCR, you also have an inductance mode as well. You can leave it in auto or you can move it to inductance or capacitance. And in inductance mode we can measure from 1 millihenry to 1 henry. That's a specific test designed for measuring the inductance of motor windings to pick up interterm faults. If we're just flipping back to the ohms and continuity, this instrument also does have a diode test. You have resistance there, unidirectional, you have bidirectional resistance, or you have the diode test there built into this instrument. A couple of other factors that are on the MTR105 that aren't on either of these instruments is temperature reading. This will read from -20 to 1000 degrees C. No temperature measurement capability on either of these two instruments. Again, quite surprising for a multimeter based instrument. Vast majority of DMMs now do have a temperature function reading on them, but it's not included in the Flir. The other one is a specialist direction of rotation test function for three-phase motors. Again, unique to the MTR 105. It's not built into either of these other two instruments. So that's pretty much the functionality of the instruments. Accuracy wise, I'll put the table up for the overall accuracy readings from the test that I do. Flir comes in at 4.73%, then the MIT 420 comes in at 1.19% and 0.49% for the MTR 105. Not a vast amount of difference between the two Meggers. I guess you wouldn't expect it. They're pretty similar technology, you would have thought, but the Flir does give a little bit away on the accuracy. Where it tends to suffer is on the transducer test that I did. MTR 105 does this quite well actually, because it's got a good millivolts function, whereas this can only measure down to 100 millivolts. So you start to lose resolution when you're testing a 4 to 20 milliamp loop over a 100 ohm load resistor. The MIT 420 here, not quite as good as the MTR 105, but still a much more respectable performance for the transducer testing than the Flir can do, which again is a little bit surprising given that it's being pushed towards the multimeter aspect. With regards to the insulation test, the actual insulation test readings fairly comparable in terms of accuracy, but in the stability of this output from the Flir IM75, it gives a lot away to both the two Megger instruments, and you also see in the table the capacitance, the accuracy on the capacitance, because it lacks that resolution again, given against the other two instruments, it starts to suffer in terms of accuracy result. Okay, other auxiliary functions. All the instruments have a memory facility to them. You have to manually select it off the test button on this one, which if I go on there, you get the save there, or you can clear it, or you can load it, depending on what you've done. Well, for both the Megger instruments, you have to go around to the actual memory function, and then you can page through all the tests that you have saved. Both these two instruments, the memory work function just works by saving it to a data number, fairly similar. MTR 105, you can see, is quite unique. You can name a test object and then save whatever test you've carried out from any of these back to that object, and you can then download that onto the bespoke software and get a test report out. For the MIT 420, there is no download option. All you can do is record the results and then go back through them manually and write them down on a bit of paper. For the Flir, you can connect via Bluetooth to the Flir Tools software, and you can save results that way, but fairly limited, just really a screenshot result. There doesn't appear to be any logging or trending of measurements that are being made with this instrument. All three instruments do have a backlight. Flir also has a built-in torch, as we've seen before, so backlight comes on there. That's the backlight on that one. Probably can't see this very well because of the lights are on. I'll try just turn the lights off, see what that looks like. Yeah, so there's the backlights. Fairly respectful for all of them. I guess the MTR doesn't really have a backlight. You just change the intensity level of the TFT screen there, and you see the light stays on a little bit longer on the Flir. Turn the lights back on. I do find that you do use the backlight a fair bit with this, because the small symbols that it has across the menus are quite hard to read, but using the backlight enhances them. And what you do also have with this instrument is a torch. You can also use, you've seen me use that in the other video where I compared this to some of the other instruments. Good for lighting up your work area if you're using the probe and the probe holder there. And so that's pretty much the instruments. and their functionality. In terms of their build and their quality, they're all very respectable quality really. All three instruments have the protective boot moulded onto the plastic cover. For the Megger, it's more of a traditional Megger case format. You do have a hanging strap on both the instruments there, but you don't have any probe holders on these. Traditionally, I guess Meggers are made more to operate with crocodile clips than they are with probes. On the back of the Flir instrument here, you do have the probe holders, again more a multimeter function, so it's included this one. You also have accessory for a hanging strap there as well. The battery compartment is 4 little screws here. You have to lift the tilt bail up to get to the bottom 2, so easy enough to get into, whereas you have a separate battery compartment which is a single screw, and a fuse compartment which is another single screw, exactly the same for the MTR 105 as well. Connection wise, we'll flip the instruments around this way. So for the Flir, you have the 3 jacks here at the front, traditional place for a multimeter, I would say. For the MIT 420 here and for the MTR 105, the jacks are on the top of the instrument, just the 2 here, so you've got no lead swapping going on here whatsoever for whatever test you're doing. For Flir, you have a little bit of lead swapping to swap between the voltage and continuity functions, and then the 200 milliamp and the insulation test functions. For the MTR 105 here, there is an awful lot of lead swapping to go through testing a motor, from the 4-wire resistance, 2-wire resistance insulation test, 3-phase insulation test if you use it, guard terminal if you're going to use that. A lot more swapping of the leads around as you use this instrument. And I think that's pretty much it for the instrument comparisons. We'll chuck them to one side and we'll look briefly at the actual packages that come with them. Case wise, for the MIT 420, it's a hard case, blow moulded. You've got a moulding for the instrument actually inside the case, provides pretty good protection and accommodates the accessories quite well. For the Flir, a bit more of a soft case, but again it is moulded inside to actually house the instrument that you've got, along with the accessories as well. For the Megger there, it's a soft case. If you see my videos on the Megger, I'm not a big fan of that soft case. You can see in front of you, this is the level of accessories that you get with the Megger in comparison to the other 2 instruments, and you really struggle to get all these accessories inside that case there with everything, and then gain reasonable access. You kind of have to tip all the accessories out all the time when you want to use something. I don't like that soft case for the Megger at all. I think they could have done much better with that. In terms of the probes, put my little terminal block in here. The Megger, you get clip-on probe heads. You can also swap them for the croc clips here as well. Superb access with these Megger leads. You can see I can get into 2.5 terminals, 4, 6, 35s there, dead easy. It's a solid moulded tip there. You can't take any of the insulation off. It remains as GS38 all the time. Very nice set of probes. The one downside to them is that it's quite bespoke. That's not a standard 4mm accessory head on there. You can't get a standard 4mm accessory to fit on. It doesn't go on, and it'll just fall off and work its way off. There's no connection through there on that. So very nice, but very bespoke. The crocodile clip again clips on, and you're kind of approaching maximum on the M12 nut there. Go onto the threads easy enough, M8 easy enough, but really are at the maximum for the M12 nut there. In comparison, leads from the Flir with the crocodile clips, you can hopefully see quite a bit bigger capacity for the Flirs, and dead easy to go around the M12 nut. And obviously the studs as well. In terms of probe access, this is better than the Megger, but the probes are worse. You can see I can't even get in a 6mm there, 2.5, no chance 4mm. I can get in the 35. Yeah, you can pull the cap off, obviously, but then you defeat the GS38 safety function, and then you can get in dead easy then. The crocodile clips, whereas the two Meggers are operating clip-on accessories, these are screw-on accessories, so you have to screw it on. So it takes you a bit longer to set the accessories up on this, but it's not that much of a deal really, I guess. The only other problem is, of course, that is also reasonably bespoke, so if you did lose one of these, you've got to go back to Flir to get a screw-on crocodile clip. In the same manner, you'd have to go back to Megger for their crocodile clips or probe tips for that aspect. Other elements, you do get a hanging strap crocodile clip for the Flir. You don't get a hanging strap with either of these other two instruments. I thought you actually might do get it with the MTR 105. I might have misplaced it somewhere, or it's hidden away in the case. You certainly don't get it for the MIT 420. But what you do get with the MIT 420 is a remote probe lead, so you can use this if you want to go down along the terminals. You can control the Megger using the button here. Good for quickly going down a terminal rail or along a distribution board or something like that. The MTR 105 will work with this remote probe, but the remote probe doesn't actually come in the package. As I said before, with these MTR 105 set of 3-phase leads you get with it, they have now moved to a standard 4mm accessory with these. However, accessories probably not quite as good as those for the MIT 420. You can see I can't actually get into a 2.5. I can get into a 4mm, 6mm easy enough, and obviously there. Likewise with the grippers here, more than a standard crocodile clip, you can get around the M8s, you can get around the M12 threads, but I'm pretty much maxing out there. I cannot get onto, well, you can just get onto an M8 nut, no chance getting onto an M12 nut there. Other accessories that you get with the MTR 105 is the T-type thermocouple here for surface temperature measurement, and the 4-wire Kelvin clips for the 4-wire resistance test function. And that's all that you get that comes with the MTR 105 there. So we'll pile him back up over there. Get him out of the way. Put the terminal block out of the way. Put our instruments back. So that's pretty much it for the video. I'd like to say I'd give you an opinion of which is the best instrument, but for me they're so different that I find it very, very difficult to do that. For the MIT 420/2 here, relatively standard insulation and continuity tester, I'd say that I'd do quite well for white goods engineer, standard industrial electrician to carry out that kind of testing with this instrument. At the other end of the scale, if you're heavily into process industries, you've got high value large motors, and you're more into preventive maintenance on motors, routine measurement of insulation resistance, storing the results and trending the results over periods of time, then the MTR 105 would meet more of your needs. It's also got more in-depth test capability with the 4-wire and the inductance mode and the temperature as well than any of these other two instruments have. And the Flir kind of sits there in the middle. For me, the only thing it really has going for it is the meter link function and being able to communicate with a Flir thermography camera, but you need a fairly expensive camera for that. You've got to fork out another $4.5 grand to get that functionality. So it's a very, very specific test. as an insulation tester, it can't compete with either of these two instruments. And to be honest, as a multimeter, it doesn't really compete with something like the Keysight E1461A or the Fluke 1587 FC. Its multimeter functions are quite poor compared to those instruments, and in fact the MTR 105 can outclass it in the DC millivolts when I was measuring a transducer. So yeah, difficult to actually select a specific instrument this time around. It really is going to be based on what you want from your test regime, and consequently selecting the most applicable test instrument. Okay, so that's it for this video. Thanks for watching. Hope you've enjoyed it and found it useful, and I'll see you again in the next video.